So now we're going to practice some graphing of ratios. So ratios are sort of a set of data, right? We essentially have an X coordinate and a Y coordinate that end up being created, especially when we put them into these tables. So we have some info. We've got a little scenario. So the pizzeria credits Remy's account $3 for every 5 pizzas that she orders. Kind of seems awesome. So we're going to complete the ratio table to sort of see how much credit Remy ends up getting depending on the amount of pizzas that Remy orders. So if we know our given information is that we have pizzas and we have credit, right? Those are the things we're comparing. We could also say pizzas to credit. And we just put it into this table to sort of help ourselves be tidy, right? So then with that, we would say, well, we know that it's 5 pizzas based on the given information. She gets $3 in credit. That just got transferred over here to the table, right? So we now know that we are going to use scaling, right? We can scale up or we can scale down to get us some more data. Well, in this case, they tell us the amount of pizzas that Remy is ordering. So from 5 to 10 pizzas, well, that just multiplied by 2, it doubled. So the credit is also going to double. So this becomes $6. Okay. Well, from 10 to 20, we could also just double that, right? We could say that doubled, and so we're going to double 6 as well, or times it by, multiply it by 2. 25. Well, there are different ways we can do this. I like to think of different factors or sort of multiples of 5. So if I am counting by fives, 25 is a multiple of 5, or 5 is a factor. So how many 5s does it take to get to 25? I'm going to use this to help me because it becomes a whole number that we can multiply by. So 5 times 5 got us 25. So now I'm going to do 3 times the same thing, 3 times 5, to get us $15 of credit. Okay, so we have our data here. We have 5 to 3, which you gets 5 pizzas, it's $3, 10 is 6, 20 is 12, 25 is 15. Okay, well, we completed the ratio table, check. And now we're going to graph the ratios. Yahoo! Okay, so in our graph, we need to first determine, well, what is going along our x-axis and what is going along our y-axis, right? So in this data table, we could think of, this might or might not make sense to you yet, that's okay. We could think of these like our x coordinates, and we could think of the credits like our y coordinates, okay? So in that case, we have pizzas will go along our x pizza, our x axis, and we'll have credits. I'm just going to put a C along our y axis. Okay, so in that case, whenever then we need to determine our intervals, right? Or the number, the increments that we are sort of growing by. So partially because my pen is big and the graph is small, I just opted to go ahead and increment, right, by intervals of 5, because we are working with sort of multiples of 5 here. And I just sort of spaced them out. So I started at the origin and then went 1, 2, 5, 1, 2, 10, 1, 2, 15, 1, 2, 20, 1, 2, 25. So as long as you have your spacing at a rate or at equivalent sort of growth as you label your axis, it's legal to do. So we have our pizzas here, and then we have our credits along the Y. So we have a 3 and we have a 15 as sort of our span. So I'm going to have to start lower than 5, obviously. I'm going to start with 2, 4, 6, 8, 10, 12, 14, 16. It's going to be up here. Okay, so I'm just sort of spacing it out. And then I'm going to graph. I'm going to go 5, comma, 3, right? So I go over 5 and up 3. And then I go over 10 and up 6. And then I go over 20 and up 12. And I go over 25 and up 15, right? So then your work is to think about, well, how much credit, if we know that this is our ratio, how much credit will